السلام عليكم ورحمة الله وبركاته. How are you everyone? Inshallah by me, you're doing well. First of all, let me make sure that the sound is working properly. Can you hear me well? Thank you very much. Thank you. Thank you, Abdullah, Amr. Thank you, Abdul Rahman. Our classmates in the class, how are you? Can you hear me? I don't know if they are able to write in the chat or not. طيب الحمد لله الحمد لله الحمد لله طيب. Welcome everyone and welcome everyone online and everyone in the class. Welcome newcomers, okay, and inshallah, I mean, I know that some students of in the class were not able to join the previous session, okay, so inshallah, Rabbil Alameen, I'll repeat what we said in the first period, okay, Tawakkalna ala Allah, because we don't have enough time, yani. Okay, please focus on every word. Sorry, today we'll decrease the area of discussion, okay, because we need to re-explain what we explained last period, okay, and add some important points to that. By the way, I sent the video of or the two videos of the last period to the Classera, so you can see them again, but I'll explain them again for the newcomers. Okay, Bismillah ar-Rahman ar-Rahim. Today is 31. Oh, 31, 8, 20, 21. This is, inshallah, topic 4. Okay. Okay, physics. 0625 0972. Okay, and this is inshallah Rabbil Alameen topic 4. Topic 4, as we said, is talking about the electricity and magnetism. Okay, last period we talked about the concept of electricity and the concept of electric charge and the concept of magnetism. Okay, today inshallah we will focus on magnetism because this is the first part. We want to focus in it. The magnetism is the ability for attracting the bodies those contain some materials like iron. Okay, so we said this property is called the magnetism. Okay, right. Now, when we, from this definition of magnetism, we can observe there are some materials those can be attracted to the magnet. And logically, we can conclude that there are other materials those cannot be attracted to the magnet. So, and starting from this point, we can classify the materials according to being, be attracted or not attracted to the magnet into two main categories. And this was the first point we were explaining last period. So we will explain them. We will classify the materials into two main categories. Okay, these two main categories are the ones those are attracted to the magnet, okay, and the ones those are not attracted to the magnet. Okay, but before talking about if the material is attracted to the magnet or is not attracted to the magnet, I want to ask a question. What's meant by attracted to the magnet? Attracted to the magnet means when you put this material close to the magnet, it will be affected by attraction. Why? Because there is an area, a space around the magnet where the magnetic field, where the magnetic force of this magnet acts. So when we put some materials in the magnetic field, they will be attracted. When we put some materials in the magnetic field, they will be attracted. Not all materials. Well, so what will happen if we bring these materials out of the magnetic field? They will not be attracted, logically. Okay, so the idea is the attraction or being attracted to the magnetic field or not depends on the existence in the magnetic field or not. Okay, this method type, if we ask ourselves why some materials are attracted to the magnet, because when we put these materials in the magnet, they become new magnets. They themselves become magnets. So they are attracted to the first magnet or the field. Okay, for example, if I have a nail, this nail is not a magnet. This nail is made of what? Is made of iron. If I put this nail close to a magnet, what will happen? It will be attracted to this magnet. Why? Because when we put this nail close to the magnet, it enters the magnetic field of the magnet. So once it becomes inside the magnetic field, it becomes a magnet because of the magnetic field. It's magnetized and becomes a new magnet. So now we have two magnets, the original magnet and the nail, which is the new magnet, okay? So the new magnet will be attracted to the original magnet, okay? Because the magnetism formed on the nail will be opposite to the magnetism on the opposite side of the magnet. This method will be explained in details later, but I want to give it its name and put it in your mind and in front of you to know that we will focus on them. By the way, I saw your questions in the Telegram. In fact, I was to answer them now, like because of the new students who didn't join the previous period. Okay, I have to re-explain. So, inshallah, I collect your questions and answer them, inshallah, with the beginning of the next period, inshallah. معلش, to save time, علشان we need to explain two periods in one, inshallah. Okay, so here the concept that I want to put in your mind, in front of you, is called induced magnetism. What's meant by induced magnetism? It means magnetic material or object is placed in a magnetic field, okay, so it becomes or gets magnetized. Abdullah Amr is asking, Mr. Does it come from induction? Yes, excellent. So sometimes it's called magnetic induction. Yani induced magnetism or magnetic induction. This term, put it in your mind because we will explain it, inshallah, in details later. Okay. Type. Now, and from the previous argument, we agreed together not all materials can undergo such magnetization. Okay, so we will classify the materials according to being able to magnetize or not. We will classify them into two main categories. The first category is the magnetic materials like the nail. Okay, so the magnetic materials are not magnets. They are not magnets. If they are magnets, I will call them magnets. I will not say magnetic material. So you have to observe that. The magnetic material, they are not magnets, not magnets. They are projects of magnets. They may be magnets later if they are placed in a magnetic field or if you magnetize them with any of the procedures, those we will explain, inshallah. Okay, طيب. The second kind is non-magnetic materials. Non-magnetic materials. What are magnetic materials? Let's remember together. I'm waiting for your answers, the ones who attended the previous session. I'm waiting for your answers in the chat. All you, with no exception. I'm following the chat now. Huh? So what is the magnetic material? They are materials. Huh? Those, huh? Excellent. Thank you, class. I don't know who class, you are the representative of the class, okay, but I don't know what's your name. But thank you for all the class. Okay. Thank you, Yusuf Usama. Thank you, Sabsian Majid. Okay, but Sabsian, this is an example. It's not the definition. Okay, well, to save our time, thank you, Zuhair, Mumtaz. Okay, to save our time, let's say the magnetic materials, they are attracted or get attracted or can be attracted, can be attracted to magnetic fields. Well, طيب, the question now is for all. The question now is for all. And I'm waiting for your brilliant answer. ابهروني. ابهروني بحقه حقيقي مش بهزار ها. طيب, they are attracted to the magnetic field. It means they are able to be magnetized or not. Excellent, Abdurrahman. Abdurrahman was the first. Excellent class. Excellent, Yusuf Usama. Thank you. Where are the others, Yama? Where are the others? We agreed together. It's not allowed to stay silent. Sorry, Abdurrahman. Sorry. Excellent. Okay, so here we said the magnetic materials are attracted to the magnetic field. Okay, it means they are able to be magnetized or not? This is the question, Zuhair. Huh? What's your answer? Excellent answer. Thank you, everyone. So we can add to the definition this description. They can be magnetized by electric field, which is called what? When they are magnetized by the electric field, it's called what? Huh? Called what? I forgot. Remind me. Astaghfirullah. I didn't forget. Remind me. When it's magnetized by magnetic field. So sorry. la, I mean magnetic field. Sorry. Thank you, Zuhair. It's called what? When it's magnetized by electric field, it's called what? Huh? Magnetism. Which magnetism? Magnetic induction or induced magnetism. Thank you, Zuhair Muqtaz. Okay, so it's called induced magnetism. By the way, they can be magnetized by induced magnetism or by the other methods of magnetism, which are four additional methods. We will explain them, inshallah. This is the definition of magnetic field. Well, what about the the magnetic material? What about the non-magnetic material? The non-magnetic materials. Okay, the non-magnetic materials simply is the opposite. So to avoid writing more, I write the opposite. The opposite. يعني cannot blah 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 cannot blah blah blah. Okay, well, so this is the definition of non-magnetic material. Well, the second point, we need to know examples of each one. Well, so let's write the examples. Here, this is the definition. Examples right after me. Okay. Number one, Fe, which is called iron. Iron. Fe, ferrum, which is called iron. خلاص يا مستر, we know Fe is called iron now. Let's focus on iron, not steel, for example. Iron. طيب. And CO, which is cobalt. Ni, which is nickel. And steel. Steel, Mr. Isn't steel a kind of iron? It's not kind of iron. This is not accurate. It's an alloy of iron. Yani iron with some impurities or some additional impurities, okay, like manganese, like carbon, and so on. But the most important point is to differentiate between ferrous and iron. This is important. Between iron and the steel, not ferrous and iron. Well, what about the examples of the non-magnetic material. The examples of non-magnetic materials, any material which is not attracted to magnetic field. Like what? Like, for example, copper, excellent, important. Like aluminium. These two examples especially should be memorized. Can I say carbon type? You can talk about all plastics, all non-metals, okay? And a large number of metals also, okay? But here, I want to focus, yes, so here, I want to focus on the following example. Surprise. Stainless steel. Oh, mister, you are kidding. You have just said steel is a magnetic material. No. Yes, I said that, but I didn't say, I didn't say what? Stainless steel is a magnetic material. So stainless steel is another alloy with other properties. Okay. In fact, not all stainless steel, all kinds of stainless steel are non-magnetic, like in the majority are non-magnetic. And in our syllabus, we use this as a famous example of non-magnetic materials. So the stainless steel is a non-magnetic material. The steel is a magnetic material. The iron is a magnetic material. And by the way, Mr. What's the difference between stainless steel and normal steel? The stainless steel is steel with additional impurities to avoid being undergoing corrosion. يعني like adding some amount of بالضبط, avoiding rust. Okay, like adding some vanadium, some chromium, and so on. So these impurities affect the magnetic properties of it. Well, so also I'll ask you to differentiate between these two, because we will call Fe as a soft magnetic material and steel as a hard magnetic material. So we have iron soft, steel hard. This is frequently asked question in the exams, by the way, in the IGCSE exams. Okay, stainless steel is non-magnetic material. Well, طيب. Yusuf Osama is asking, are there atoms magnetic, like, for example, iron atoms? Can it be magnetic or not? طيب. Inshallah, when we explain the idea of the domain, okay, the magnetic domain, inshallah, we will answer this question, Yusuf. معلش, I'm sorry, لأن أنا بحاول أضغط الوقت علشان أشرح أكبر قدر ممكن عشان أقول اللي قلناه الحصة اللي فاتت ونزود عليه جزء جديد. تمام؟ فبما ان البوينت دي جايه ان شاء الله فهنقولها في وقتها. ماشي؟ شكرا حبيبي. Thank you very much. Well, so here till now the non-magnetic material stops. It will stop here. It will stop here. خلاص. We don't need to say anything about non-magnetic material. But we will, inshallah, continue with the magnetic materials. So the magnetic materials will be classified, inshallah, Rabbil Alameen, into two new, the magnetic materials will be classified, inshallah, into two new classes or categories. The first one is called magnetically soft materials. We can say soft materials best. And the second one is called magnetically hard material. Well, now we want to differentiate between these two kinds of magnetic. Both are magnetic, by the way. Okay, both are magnetic. We want to differentiate between both. Okay, no difficult or strange thing. All what we will say is that easy come, easy what? Huh? Easy come, easy what, ya جماعة? I'm waiting for your answers. It's a famous statement. Easy go. This is soft. What does it mean, Mr.? It means the magnetic material easy magnetize and easy be magnetized. يعني easy to be magnetized when it's placed in the magnetic field, and easy to be demagnetized when it's removed from the magnetic field. طيب. So, can I say they maintain or retain their magnetism for long time or for short time? I'm waiting for your answers. Excellent. Short times. You said easy to demagnetize. بالضبط. Thank you, Zuhair. جماعة, where are the others? Where are the others? This is Zuhair and I'm so sorry, Yusuf Osama. Thank you, class. Okay, so it's easy to be magnetized and easy to be demagnetized. Well, so it retain or maintain or keep magnetism for short time. Well, so what about the magnetically hard? The magnetically hard are extrapolation بقى يا شباب يعني. I'm waiting for your comment. يعني you should tell me what I want, what I need to write. Excellent, mashallah, ممتاز. Thank you, everyone. Thank you, class. Thank you, Abdul Rahman. Thank you, class, and Abdul Rahman. Thank you, Yusuf. Okay, so they are. لا, Yusuf, thank you. It's a good idea. But in fact, here it's hard. Also, it's hard to magnetize and to, يعني hard also to demagnetize. So it takes much more time to be magnetized. But when it gains the magnetism, it keeps it sometimes for years, several years, even when it's brought out of the magnetic field. Okay, well, so they maintain or keep magnetism for a long time. Well, examples, mister, excuse me, with pleasure. We mentioned the examples a few minutes ago. Okay, the example of the first one is what? Huh? Yes, is iron. The example of second one, excellent answer, mashallah. Thank you, Abdul Rahman. Thank you. Class, I saw your question, Yusuf. Okay, is steel. So I want you to observe that this is the example here. This is the example here. Well, طيب. Can you guess which one will be used to make a temporary magnet? We sometimes we need temporary magnets, like in case of electromagnet, okay, like in case of loudspeakers, like in case of electric rings, fire alarms, and so on. Okay, so which kind is used to make temporary magnet? The magnetically soft or the magnetically hard? Yes, excellent. The magnetically soft. So its use is in temporary magnets. In temporary magnets. Okay,